page 11 in your books. One thing I want to point out this year, one of our administrative initiatives is we need to make sure our standards are posted for every single lesson that we do.
You want me to go top?
Yes. Okay, on this one, instead of posting our standards in the room, we have it on the first, one of our first class slides every single period. But you'll notice every lesson begins with these, right? So if an administrator comes into the classroom and asks you what you're learning today, please turn to this page in your module. We do go over it. It is on the board. We have them posted. I don't want to have to write this every single day, okay? So it's a great way for us because the book does a good job of breaking it down. So here's what we're doing today. We're going to use powers and exponents to write prime factorization of a number. We're going to determine the greatest common factor, two whole numbers less than or equal to 100. We're going to rewrite the sum of two whole numbers with a common factor as a product using distributive property. In other words, we're going back to the work we just did the other day. And you're going to determine the least common multiple of two whole numbers less than or equal to 12. So quite a bit that we're going to unroll. That's why actually you guys don't have homework today, because this lesson is going to take us a couple periods to get through because we've got a lot to unfold. We're going to start with our review activity at the bottom. So again, follow along. Please mark your text along with me because it's going to help you understand what to do. Here we've been given an array of numbers. We are going to circle the prime numbers. We're going to cross out the composite numbers and use a box to identify any number that is neither prime nor composite. So you really have three sets of directions you're following. Circling prime, crossing out. That was fun. There we go. Crossing out the composite numbers and identify any number that's neither prime nor composite. So we've only given you 20 numbers. We're going to give you 2 minutes. Go through them, following the directions. There should be a circle, box, or an X over every single number from 1 to 20. Go ahead and get started, guys. Okay, first off, let's talk with some of these definitions. What's a prime number? Go ahead.
A prime number is a number that is multiplied by 1 in itself.
Okay, I like overall what he said. I don't like the fact he said multiply. So I can multiply any number by 1 or itself, right? Yep. So the word you were looking for is factors. The only factors of the number are 1 in itself. So again, back to proper terminology, right? You have to speak mathematics properly. You got to learn the vocabulary in order to speak properly. So you are correct on that. What's a composite number then?
A composite number is a number that can be divided by, or a number that has a factor of 1, or itself, 2, and another number.
Okay, I like everything you said except the fact that it's 1 and itself, not 2. We have a lot of composite numbers that don't have 2 as a factor. But 2 is a factor for most composite numbers. Okay? So that is your real big definition. If you didn't know those, what resource do you have in your hand that you could have used to figure it out? Then? That's okay. Look at this, guys. If you go to the back of your book, there's a glossary that has the definitions of all of these words. So if you come across a word you don't know, we've given you a built-in way to find it. See, we really do want you to be successful, guys. So let's go through our numbers real quickly. Okay? Let's start at 1. How many factors does 1 have? 1. So is it prime? No, because it doesn't have 1 and itself. 1 is itself. Is it composite? No. So what would we do to the number 1? Stella? A box. This is the one that is neither prime nor composite. So we talk prime and composite numbers. 1 is a special one, special circumstance, because it actually isn't either one of those. That makes a really good trick test question. If we're talking about prime numbers and ask you if 1 is prime, the answer is no. But it's also not composite. It is neither prime nor composite. What about 2? Prime is just 1 times 2, right? What about 3?
Prime.
Prime, just 1 times 3. What about 4?
It is composite.
Composite, because not only do I have 1 and 4, I have 2 times 2. What about 5? Record? Prime. What about 6? Composite. 1, 6, 2 times 3. We've got 4 different factors. What about 7?
Prime.
Prime. So we're circling that one. 8. Composite. 1 times 8, 2 times 4. 4 sets of factors. What about 9? Composite. Because not only do we have 1 and 9, we have 3 times 3. So it actually has 3 factors. What about 10? Composite. 1 times 10, 2 times 5. Whoops, that should have been crossed out the box. What about 11? Prime. Just 1 times 11. 12? Get people that haven't done yet. Good. Composite. What about 13? Prime. What about 14?
14 is composite.
Composite. 15. See that? Composite, because we have 3 times 5 in there as well, right? 16. Scarlett? Oh, it's supposed to be crossed out. Thank you. Good job. Bonus points for Scarlett. Excellent. 16. Stella?
Composite.
Composite. 17. What other than 1 and 17 can I do? Nothing. So that's prime. It's 1 and 17. 18. Okay. Yep. Composite. 19.
Prime.
Prime. 20. Dina? Composite. So what we've just done for you is we've gone through the first 20 numbers and given you a complete list of all of your prime and composite numbers. I want you guys to add a special note right here. I want you to write this in your books. 4 key numbers. We are going to refer back to these 4 key numbers repeatedly throughout the entire school year. In mathematics, every number we do is really built off these 4 numbers all the way up to 121. Those 4 key numbers are 2, 3, 5, and 7.
Make sure you write it down.
2, 3, 5, and 7. So what do I mean about these being so key? Let's just talk about a couple examples. If you'll look at our list, you'll notice something about it. 2, 3, 5, and 7 were the first 4 circled numbers. They are our first 4 prime numbers. Every other number on that list comes back to it. So let's take, for example, 15. If I look at 15, can I divide 15 by 2? Can I divide it by 3? Yes, 3 times 5. That tells me automatically that's a composite number. What about 19? Can I divide 19 by 2? No. Can I divide it by 3? Can I divide it by 5? Can I divide it by 7? If I say no 4 times, that means it's a prime number. Let's try another number. Let's pick one that most of you guys may not realize. Let's go with 51. Can I divide 51 by 2?
No.
Can I divide 51 by 3?
Yes.
How do you know?
51 divided by 3 equals 17.
How do you know that?
Uh,
Does anybody know the trick to figure it out quickly?
You take the 2 numbers, and 51 has 5 and 1.
Uh-huh.
So you add them together, and you get 6. And if 6 is able to divide by 3, then that is
Perfect. She said it exactly right, guys. You just add the digits together. 5 plus 1 gives me 6. I can divide 6 by 3, so I know I can divide 51 by 3. You then take the next step and find out what it is. do the math, and you know that it's 17. Okay? But if you didn't know immediately, it's a very quick way to check to see can I divide it by 3. So let's check another number. Let's go with 53. Can I divide 53 by 2? No. Can I divide 53 by 3? Can I divide 53 by 5? Can I divide 53 by 7? We just said no 4 times. That means 53 is a prime number. You see how fast it is to figure that out if you'll go to your 4 key numbers? It is really important that you know your 7 facts, because there is a trick to 7, but quite frankly, the trick is more complex than just doing the mental math. The really quick trick for 3 is add the digits. That tells you it's divisible by 3. You should know 2's. If it's an even number, I can divide it by 2. You should know 5's. If it ends in a 5 or a 0, you know you can divide it by 5, right? So it's very easy to check all 4 of those numbers. And if you do so, it's going to tell you, do I have a prime or a composite number? Everybody good so far? Yes, sir.
Can you show us the trick that for 7?
I could, but I'll be quite frank. Even if it's a super long number, to me it's actually easier to do the mental math division than to do the trick. If you really want to know, just Google it. Because that's what I did. And I Googled it and I said, yeah, this is stupid. Okay? Go back and forth. I think we're going to skip these 2 because the other earlier classes had less time. Towards the end of class, we may come back to that if we end up with a lot of extra time. But I want everybody to just go ahead and go to page 14 for now. We're going to cross out this part because we're not doing the activity. I need everybody to have your highlighters or something to mark your text with. Again, if you don't have one, you got the student desk, you borrow a highlighter or a colored pencil. But we got a few things we're going to mark in our definitions. Okay, you should have your highlighters out. Go ahead and underline. We have a factor tree. A factor tree is a way to organize. Let's see. I've got to switch it. Sorry. Switch it to highlighter makes it easier. That way I don't erase it. A way to organize the prime factorization of a number. So this is basically just an organizational tool, guys. A factor tree is one of the ways. Later on we'll teach you another one. But for now we'll focus in on the factor tree because hopefully most of you have at least seen this at some point in elementary school. The way the factor tree works is actually pretty simple. We start with the number I'm going to find the factors of on top. I write the number, and then I start drawing branches. This is why we call it a tree. Let me give you a Mr. Moore hint. This will be easier for you, and will come out in the proper order if you just follow your 4 key numbers. So although you are allowed to pick any factor pair, I would always start at 2. Say, can I divide it by 2? If you say yes, start there. Make that your first factor pair. Okay, in this case, they did that. They said, okay, well, I can do 2 times 15. That's 30, right? Anytime you get to a prime number, you circle it. That branch of the tree is now dead. I can't go any further. It's already a prime number. 15, though, I can still break down, right? Can I divide 15 by 2? No? Can I do it by 3? Yeah, so that's the next one I'll use. So I go 3, and it's 3 times 5, which is another of my 4 key numbers. So I know that I am done. Dang, your factor tree is complete. Now, there's a difference. The factor tree is your key, your tool to organize the material, but I still need to write the prime factorization. A prime factorization is actually a multiplication sentence of all of the prime factors. So all I'm going to do is I'm going to take the numbers that I just circled, and I'm going to rewrite them with a multiplication symbol in between. So it's 2 times 3 times 5. Remember, we don't use x's for multiplication anymore, correct? If I'm writing it up here, you should have it in your book. If I have it on the board, you should have it in your book. So that is how we write the prime factorization of the numbers. So the factor tree helps you organize it, figure out what the prime factors are. we actually just put the dots in between the numbers to show the prime factorization. So just to show you what just happened, what's 2 times 3? 6 times 5? 30. So it's basically another way to rewrite 30. Everybody okay on this one so far? Okay. Number 2 is create a different one. I'm going to skip that because I really would prefer you guys focus in on your 2, 3, 5, 7. If you'll focus on your 4 key numbers, it's going to make all of this far easier for you. So let's turn the page. Go to 15. Here's your chance to show me that you're listening and can do what I've asked. You are going to create a factor tree and write the prime factorization for each number. You got 2 parts. Create the factor tree and write the prime factorization. Everybody clear on what you're doing? Okay? We've got 3 numbers for you, A, B, and C. We'll give you guys about 7 minutes to do all of this. Go ahead and get going. Okay, let's go ahead and go through these. Now, I will say up front, again, there is any number of factor pairs you can use for these numbers because there are a lot of different factors. My Mr. Moore hint is go through your 4 key numbers in order. Because if you do that, this is literally going to line them up for you in order. It makes it super easy to do. And it actually cuts down the amount of thinking you have to do. Because I can just go through the number and I say, should I divide 24 by 2? Yeah, so I do it. So my first tree is going to be 2, and then the number I would multiply it by to get to 24, or 12. Why is that good? Because I know that first branch is going to be dead. I've got one of my prime numbers. And then I just check again. Can I divide 12 by 2? Yes, so I do another branch, start with 2, 2 times 6. And then I say, can I do 6 by 2? Yes. So I do another branch, 2 times 3. Well, 3 is one of my 4 key numbers. I know I'm done. See how easy a factor tree can be? Then writing your prime factorization is even easier because literally all I'm doing is going down it. 2 times 2 times 2 times 3. There's my prime factorization. Yes? Again, there are a lot of different ways. I could have used 2 and 12, 4 and 6, 3 and 8. Any of those would get you to the same answer. Doesn't matter. Okay? So let's look at 81. Can I divide 81 by 2? No. Can I divide by 3?
Yes.
If you don't know, 8 plus 1 is 9. I can divide 9 by 3. So you know really quickly you can. Then you just got to figure out what number I use. In this case, it's 3 and 27. Again, 3 is one of my prime numbers, so I know I'm done. Can I divide 27 by 2? No. Can I divide by 3? Yes. 2 plus 7 is 9, so I know I can divide it by 3. Gives me 3 times 9. Can I divide 9 by 3? Yes. 3 and 3. So I can now write my prime factorization. I have 3 multiplied by itself 4 times. 96. Just go through the exact same process. Can I divide 96 by 2? Yes. So I'm going to start at 2. 2 times 48. Can I divide 48 by 2? Yes. 2 times 24. Can I divide 24 by 2? Yes. 2 times 12. Can I divide 12 by 2? Yes. 2 times 6. Can I divide 6? Oops. Circled the wrong one. Can I divide 6 by 2? Yes. 2 times 3. Guys, do you see how those 4 key numbers can get you there very quickly? Now, literally, all I got to do is rewrite them. Just, got it? No, 9 is not prime. I can divide 9 by 3, right? So if you started with 9 and 9, you'd still get there. So just to real quick show you. 81, if I did 9 and 9, are either of those prime? No. So I can do 9, 3 and 3. I can do 9, 3 and 3. Did I get the same answer? Yeah.
It's shorter.
It can be shorter, but especially in a number like this, there's a lot of different ones I could have done for 96. But the good thing is, it's now all laid out. How many 2s do I have? 1, 2, 3, 4, 5. They're all in order. So I know my prime factorization, 1, 2, 3, 4, 5, and then a 3. So yes, Rowan, there are any number of factors you can use. You can use any of them. Again, that's just kind of a Mr. Moore hint and try to make the math easier for you. Okay? Is this making sense so far? Everybody good to this point? Because now we're going to throw another level into you. So pull out your highlighters again. We've got 3 more words we're going to add. We have a power, we have a base, and we have an exponent. Using your highlighters, let's look at our definitions for each of those. A power has 2 elements, the base and the exponent. So when I talk about power, I'm talking about the entire thing. Okay? Or we have, a base. The base of a power is the factor multiplied by itself repeatedly. Or in this case, the base is just the number 2. The other thing we have is the exponent. The exponent is the number of times you use the base as a factor. So this little number is the exponent. Most of us think of an exponent as the whole thing. Most commonly, we think of the power as an exponent. The exponent, though, is actually just the little number. It's telling me how many times I'm multiplying 2 by itself. So, who thinks they can tell me what the value of 2 to the 4th power is? What does it actually equal? Lena?
8.
8. Awesome. Does everybody agree with her? Anybody not agree with her? Sawyer? Sawyer, you're literally the only person out of 60 in the room who's raising his hand. Do I? So, you guys want the good news or the bad news? The bad news is you all just made the single most common error people make with exponents. Y'all did not pay attention to anything I just said. The good news is it's easy to fix. And the easy way to fix it is to actually look at what we wrote. We said it was 2 times 2 times 2 times 2, right? So if I go through and I do the math, what's 2 times 2?
4.
What's 4 times 2?
8.
What's 8 times 2? So what is the value of 2 to the 4th power? 16, not 8. Please don't make that error. That is the single most common error they make. I highly recommend when you are doing math using exponents, rewrite it in what we call standard form. That's this. If you rewrite it in standard form and just go through and do the math, you will get it right. If you just look at it and say, oh, 2 times 4, you're going to get it wrong every time. Okay? So, if you're working an exponent problem, they ask you to find the value. Take the time to rewrite it in standard form and go through the math step by step. Everybody good? Okay. So, that being said, we have a little hint over here. So, hopefully you still have your highlighters out. You can read a power in different ways. A common way, we say 2 to the 4th power. So we say what the base is, and then we say what the power is. Or you can say 2 raised to the 4th power, or 2 to the power of 4. I mean, literally, there's a lot of different ways you can say that. And I didn't do this earlier, so hopefully I'll remember later. But with earlier classes, there are 2 special ones that we use. So, I'm going to add these 2 definitions in for you. So we have 2 special ones we use with exponents. Squared means to the 2nd power. So for example, if I did 4 squared, it would look like that. So saying 4 to the 2nd power, I would just say 4 squared. Another common one we use is, that's a terrible C, let me redo that, cubed. Cubed is to the 3rd power. So an example of that would be 4 to the 3rd. So that would be cubed. Okay? So add those two notes in, because you're going to hear those terms a lot when we talk mathematically. We will say the term squared or cubed. We're talking specifically about exponents. Squared is specifically to the second power. Cubed is specifically to the third power. Okay, those are the only ones that have special words for them. We don't have special for fourth or any others. So now we have two additional pieces we need to do. We need to identify the base and exponent in each power, then write each power in words. So you got two parts. Identify base and exponent, and then write them in words. So unfortunately, we're down to 5 minutes in class. So I'm going to give you guys like 2 minutes to do this, because we need to finish this out for the recording. Okay guys, I know the time is short, and so I want to get in the rest of this before the bell rings. So, for part A, what was our base? Base was 7. What was our exponent? 5. How would I say this? 7 to the, I heard power of 5. Perfect. That one doesn't use one of our special phrases we just used. So you use either of the others. Keegan, I don't think I said to put stuff away yet. Because we haven't even done the bottom three yet. So you should have your book open and be writing all this. Okay, what's our base for part B? 4. What's our exponent? 8. How do we say it? Okay, I'm going to use the other phrasing just to give you another example. So I would say 4 to the 8th power. Either one would be correct. The idea is just to get ready to say it. Okay, so now what we're going to do for our last step for today, write the prime factorization for each number in question 3 using powers. So we're going to go back to the ones that we just did, and I'm now going to rewrite this using exponents. So how many 2's did I have for 24? 3. So I'd write that as 2 to the 3rd times 3. Simple, right? Part B, how many 3's did I have? 4. So that one is just 3 to the 4th power. Part C, how many 2's did I have? I keep saying them backwards. I'm giving you the answer up front. How many 2's did I have? 5 of them. And then a 3. So I would say 2 to the 5th times 3. Just as a side note, if I don't see any power given there, that is inferred to be a 1. So if it's just a number, the power is 1, which just means itself. Technically, a number to the 0 power will always be 1, regardless of what the base is. Any questions on today? Okay, great job, guys. Thank you very much.